Thank you very much. Thank you very much, first of all, for the introduction to the chairman, and thank you also for the organizers for this invitation to join you and show you a little bit of what we have been doing in Latin America in the recent years. And because of the time, and as you have heard, it's a limited time for each one of us, we cannot get so much into technical details, but what I want to give you is just a glimpse of what is happening in Latin America in terms of bridges, seismic isolation, energy dissipation. It's happening. After the presentation from Japan, I'm concerned a lot, of course, because we have to focus on quality, and you will see that in my conclusions, but I think it's clear that we need to focus on what are the risks of all seismic isolation and why we need to do it properly in the right way. So just to start, of course, I mean, we know the importance of bridges, we know the importance of resilience, we know, I think for all of us is clear. We also don't have to tell basically in this room what seismic isolation is, which is so usually always the way we start because it's still a topic that in many parts of the world takes time to digest. And I think here is the place where we can be very open about it. And what I want to show you is our reality, and you have seen probably this a lot, and this is where we are. You can try to find Latin America, try to find Japan. We cannot find it. It is just the reality. We know the next earthquake is coming and it's going to hit us hard, and we need to be ready. And of course, seismic isolation and energy dissipation is an alternative that is working, and nowadays is also coming down to Latin America, which for many years was a challenge because of many reasons that I will explain a little bit in detail. So as a glimpse of what we have in Latin America, these pictures you see here are not the only ones we have done in Latin America. There are many of them. I have had the pleasure of being part of most of them, but it's still in process. You know, there are 35 projects over there, and you can see already the countries that are jumping into seismic isolation. Mexico has been there, especially in bridges, for quite some decades, and I was not even aware of it in many cases. But I think other countries are now jumping. Of course, what Chile has done, what Colombia is doing at the moment is quite interesting. So I will just go through this project, not from the very technical side. I have the details of all the projects. If you want, please let me know. But in the time we have, we're just gonna go through them just to take a look at what type of bridges, what type of structures, and the way they have been solving these projects. And of course, technologies, I mean, these are the most popular ones. I just wanna, fortunately in Mexico and Latin America in general, there are plenty of manufacturers now providing solutions, which is also good for competition. And I emphasize this point because, of course, cost for Latin America matters. It's a region that not necessarily has the means to use technologies in the best of our abilities, but I think now it's changing because of this, because now it's a product that is more affordable for the markets, and I have some evidence of that. And of course, there are different technologies, different companies, different manufacturers. Most of them are all now in Latin America pushing for this, and it's amazing. But of course, we need to be careful in the way we do it. But these are just as a reference. Some of the case studies that I want to show you about, especially I'm going to start from the north to the south, not because I'm Mexican and I'm going to put Mexico first, but it's just in the north. And this, for example, is a viaduct that has been there for almost 20 years in the north of Mexico, in Mexicali. It's equipped with elastomeric isolators. It has been there for a while. There have been some issues in terms of let's say, seismic joints, not only the expansion joints, but the proper joints for seismic isolated bridges. I think it's a topic that we need to be very careful about because we lose the continuity of the operation of the structure if we don't have the proper joints. And sometimes we neglect that from the actual design, and it's important to keep in mind this. And this project has a little bit of an issue. There are other projects like this in Guadalajara. It's a big city in Mexico. This is equipped with dampers for also quite some time. You can see a little bit under the structure, you will see the 4 dampers connecting the superstructure of the bridge. It's quite interesting. It's a beautiful bridge in the city. Very few people know that it has dissipation devices underneath, but it's quite an interesting application. Again, in a beautiful setup. Another similar bridge, but this one is also in Guadalajara, very similar to the one in Mexicali, also with elastomeric isolators, steel structure, as you can see. Now the piers are concrete, but more or less in a similar path as the other one. You see a little bit there also the devices. Guadalajara is at the moment not the place. Actually, it's happening quite often that they think that they don't have that many earthquakes, and probably have seen that around the world a lot, and they do have, but they are probably not so they don't remember that well, unfortunately, but they do have seismic isolated viaducts there. And now what's happening with the introduction of the railway industry in Mexico, which has been left aside for many years and now is being pushed by the actual government, is we have viaducts like this for railway bridges, and now these are equipped with the energy dissipation devices, which are quite impressive. You will see the picture there. And so this is now another reality in Mexico. Now, of course, has to do a lot also with the, let's say, now it's a complicated term, but the globalization of knowledge. Many of the companies designing these viaducts are coming either from Europe or from the US or Canada. So of course, the know-how exchange is happening, and also the manufacturing capabilities come, of course, from other countries in these kind of devices. But now it's a reality in Mexico, and it's happening more often. You see there the sizes of the devices. It's quite an interesting project. Quite impressive for let's say, for a country which is not so familiar yet with devices, but it's interesting that we're jumping now into that. And especially in the previous presentation, you saw the importance of testing. And that's when Latin America and everything you have seen here, it's a little bit of a challenge because we don't have a proper testing facility in Latin America yet. So all the projects you have seen here, most of them have been tested in Europe or in the US. And that's normal, and we can afford it at the moment, but the reality is we need to have the in-house capabilities in our countries to properly judge if we're doing the right way with the devices. Another project, this is a precast structure. It's a viaduct in the city of Puebla. It has 1,400 elastomeric isolators type LRB. So it's a massive project. It's quite long, it's 13.5 kilometers. So it's quite an emblematic structure. Again, there are many things that need to be checked, but in principle, it's working in a city that requires this. We had an earthquake in 2017 in Mexico that reminds us that there's plenty of things to be done. And the structures, of course, with seismic isolation in that earthquake or energy dissipation, in Mexico City, we had some in that moment. They performed extremely well during the earthquake. So that's another reminder that these technologies work and work well, and we need to just continue properly and in the, let's say, with the proper studies, developing its use. You see some of the pictures there. It's quite long. Again, it's 13.5 kilometers. It's quite a massive structure. There you have another view of the viaduct from the top. And one more, and you saw some big bridges. I always want to emphasize that we don't need to focus only on big bridges. And I was so surprised that Caltrans is also thinking now on having this focus on normal bridges, not the fancy one, not the big ones, the ones that serve the most people actually in the cities. And now it's happening. This bridge is in Tijuana, in the city next to the US. And they have this overpass that you can see there, which is steel structure, which is now equipped with pendulum isolators. You see a little bit there the pendulum, which is special care on the seismic joints. They focus also on the proper joint that will allow the movement. Here, if I recall correctly, the movement is about 300 millimeters in any direction. So plus the fact that you have pendulum, you will have some vertical movement. So you need to account for that in the proper joints. And this is something important to keep in mind. Some of the pictures of the joints, which I think it's important to always consider because it's not always the case. There you have some pictures. This is a very small bridge. This is nothing fancy. And it already basically proves that you can do this kind of technology and afford it for this application. So that's the bridge, the overpass. Guatemala is also working on seismic isolation. This is one case of a rather not so young bridge. It needed to be retrofitted. They did the work, and they actually include now elastomeric isolators as a way of improve the performance. You will see a little bit of the work there. Again, I cannot really go so much into detail because of time, but you see there where the isolators are. They have these steel elements that are now attached underneath the superstructure to control now with this. Here, a lot of questions come into mind, especially the space around. I mean, we have to be always careful about these things, but now it's a way to improve this performance of this structure. This is the 𝗓𝗍𝒄 bridge in Guatemala. And the last thing I know is there are some issues about some pounding. So there's might be a need to check a little bit the space around, not even for earthquake conditions, but even service. Another interesting application in Guatemala, they have plenty of these truss bridges that you see there. But they are mostly emergency bridges that they are now left there, and they use them conventionally, but they are very old. And they don't have also the means to do a lot of the work. But what interesting thing they are doing is they are building these towers. The rehabilitation process is through these concrete structures, and then they put cables that now basically support the whole superstructure. The interesting thing is they never stop the traffic. They have to do it basically because it's the only thing that connects these areas in this part of Guatemala. So it's quite of a challenging process. This is one of them. There's 𝗓𝗏𝗏. This is still in progress. Also similar process. You see how they work on the towers, and then they basically hang the bridge. It's a sustainable way, let's say, because you can demolish it and everything. They don't have the means at the moment, especially for many other reasons, but it's a topic, and they have found this solution which Also includes seismic isolation on the connection with the substructure. But again, the implementation of existing structure with not proper spacing could be a challenge. So that has to be taken care properly by the design team. And of course, not only, this is also quite encouraging, not only let's say all existing bridges and deficient bridges are being improved now in terms of performance with isolation, but also they are now creating new bridges, like the one you see there. It's now in progress. It's a structure also with the pendulum isolators that you see there. And it just shows that, again, these countries, we don't have the strongest economy, we don't have the strongest meat, but if you consider the benefits and you compare the conventional structure, actually it makes sense now, especially now that it's more affordable because we have many suppliers basically in the market. Now, El Salvador is also pushing, especially now with the new president, is pushing a lot of development, but still, I was just gathering this information for you, and this is one of the bridges, the Densan one. It's, let's say, a conventional bridge. It's equipped with seismic isolation. Especially this second one is just a conventional overpass that you will see everywhere, but for them, it's really one of, actually when I took this picture, they presented as a mega project in El Salvador. And even though for many of us could probably not be the case, it is for them. You know, it's not well developed in terms of infrastructure, so it really makes a difference. And the fact that they are isolating these structures also means a lot. And also another project in El Salvador, also a new structure you can see there. Also, I mean, they are improving in many ways, not only structurally speaking, but also architecturally speaking. It's quite now interesting what they are now aiming. And this one I want to emphasize a bit more than the other ones because this is from Nicaragua. Nicaragua it's a country that, economically speaking, is one of the, let's say, the less strong countries in the Americas. They are really having a hard time in many ways, and even though this is complicated, they are now working on a seismic isolation as well. You probably remember that in 1972, they had a terrible earthquake that really destroyed most of the city of Managua, which was a vibrant city growing up and a lot of buildings. Now you go to Managua, it's completely flat. No one is building anything because they are just afraid. And now they are building for the first time some viaducts, but they won't risk it, you know. So now they are going for seismic isolation in order to have this level of performance that they require, because even though it was 1972, they haven't forgot. You know, they still remember clearly. So these are two viaducts that they did about, I would say, 10 years ago. And they're equipped with elastomeric isolators as well, with also, which I really respect the fact that they go for proper seismic joints, proper modular joints in this case, which allow the movement in this case. The picture is 45 centimeters in any direction, which is quite a bit of movement, and the joints are ready to take it without having any damage during the earthquake. This is essential because it doesn't matter if you have an amazing isolator, which anyway we know is always a challenge, but also you need to be able to allow that movement. So they did that about 10 years ago, and now they are just finishing these two viaducts that they just finished like a month or 2 months ago. We have been part of that project, especially supervising the whole situation. And as you can see now, precast structure, they are also jumping into new methods of construction, and they are using elastomeric isolators. In their country, they are still very much into elastomeric isolators. They don't want to touch the pendulum for some reason, which is absolutely respectable. But you can see that they are now jumping into these two viaducts, which again, probably for many of us are not that impressive. For them, is the most impressive structure there is in Managua at the moment. And again, now they are going for this solution because they know. And look, I put this picture just so you get a glimpse of what Managua looks. And as I told you, it's just flat. There's no one daring to make a tall building because they are really scared about the earthquake. So I think the right approach, of course, is let's do engineering and let's try to keep it in the proper way. So, and again, that's Nicaragua. And of course, there's another country, which is Panama, which has a little bit less problems in terms of economy. They are doing well. And of course, they have all these bridges because of the Panama Canal. And of course, this is the third bridge crossing this channel. And it's equipped with a lot of devices, spherical bearings and so on. For our purpose, is viscous dampers, massive viscous dampers as well. I'm happy to share with you some of the details of the devices. And it's quite impressive. Panama, of course, within Latin America is kind of a different case because they have kind of a strong relationship with many countries. They have a very strong economy because of the profits from the economic activity. But these projects are now equipped also with this technology. I have to say most of the engineering here comes from another country. Most of the other projects you're looking at are basically designed, are basically worked by the local engineers with the local capacities, which is essential also for our region to jump into this properly. Okay, so we go now to Colombia. My wife's from Colombia, so I have special appreciation for the country. And we also have quite interesting structures like the one you're just looking at this 𝗕𝗲𝗃𝗀𝗃𝗀𝗃 viaduct equipped with pendulum isolators. And they are now also retrofitting a very important number of existing bridges. They are very fond of the cantilever bridges, as you can see there. And now they are equipping all these technologies with seismic isolation with existing conditions, which is quite a challenge. And normally, of course, the natural thing is to expect probably to have the isolation system on top of the piers below the superstructure. They are working down basically to the foundation, and they are creating the whole new base for the seismic isolation system. Quite interesting. Here I have to say that I'm very impressed and really admire the work of the company 𝗕𝗲𝗃 from Juan Sobrino. They have a very strong presence in South America, and they are doing really a very strong push for seismic isolation with a very creative way to solve issues like the one you see there. So what they are working right now is basically in rehabilitation of this structure with pendulum isolators. I will show you a very brief animation so you can see how it works. See? Okay. So you see there how they work basically in the foundation. They create the base. So it's quite a bit of a work. It's quite a bit of lifting as well. And this kind of structure, you saw a little bit how the whole geometry it is of this. So they work underneath. They basically lift the whole structure. And once they lift it, they put in the new isolators, pendulum isolators, which we have, of course, also some vertical movement. So it has to be all accounted. And that's how they are basically now rehabilitating a lot of concrete bridges in Colombia. They have plenty of the same type, so they are working quite intensively now. This is one of the pictures. We have another viaducts, also very similar. All of these work basically in the connection with the foundation, putting this system with pendulum isolators, which is not an easy task. Requires a lot of expertise. And this is the important part of this. I mean, I'm presenting now Latin America as a whole region, but we're plenty of countries, and we're plenty, even though we're very similar, also similar language, we speak differently a little bit. But the reality is we also need to share this knowledge. We need to know that Colombia is doing this because maybe in Mexico we can solve an issue because of that, or maybe we did that in the past and we're finding out that there are some risks associated with that. So the sharing this knowledge, which is of course the aim of this kind of events, is essential for us to know what is happening around. And if you guys might be using this kind of system eventually for your countries, or you detect that something can be done in order to improve it, please, that's the idea. Let us know so we can also continue improving. Some other viaducts, all these are different. They look similar, but these are different locations, different structures. So they are working strongly there. And also, they are working now in the city of Bogota. There are some structures also with seismic isolation, especially these viaducts as well. They include elastomeric isolators. There are some now local manufacturers basically supplying this kind of technologies, which is great as long as we have the proper way to measure their quality, to measure their performance. And I think that's where we need to put the finger now in this kind of structure. So this is one example in Bogota. Then, of course, we go to Ecuador. Now a little bit going south. Ecuador also has done a lot in the recent decades in terms of buildings, in terms of hospitals, but also in terms of bridges. You can see one of the most iconic ones is this one that you see there, Las Caras Bridge. This bridge has already suffered from a strong earthquake, and the seismic isolation basically kept it going, and that was a very, very nice success story about that. But, and of course, it's a really emblematic structure in Guayaquil and an amazing study case. But also there are some other new structures coming up with the seismic isolation system as well. Here they are going a lot with the triple pendulum. It's one of the technologies that are now available also for them. And again, I have to emphasize also, economically speaking, it's affordable. It's something they can actually access. And I think that's the whole difference, because even though for many other countries, probably the price is not the biggest challenge, for us in Latin America, whenever you say technology, they get scared and don't want to hear anything. So you have to really do a little bit of the convincing part of it. So you see there a little bit of the technologies, beautiful bridges also in Ecuador, equipped with these technologies, coming up quite impressive. And this is the 𝗕𝗂𝗃 bridge, the 𝗕𝗂𝗃 bridge. This is another one, 𝗕𝗲𝗃 bridge, also equipped with triple pendulum isolators. Some of the pictures. And the same goes to Peru. Peru is actually, and I really have to focus on bridges here because of course something is happening also in buildings. And in many cases, buildings are now becoming quite strong perspective for the isolation and for dissipation, but bridges, Peru is also going on in this direction. These are structures that are basically now equipped with elastomeric isolators. Here you can see a little bit also the switch, how every country has their own basically mindset in terms of what type of bridges they like, what type of structures they want to create, steel, concrete, depending on the basically local criteria. But this is just an example in Peru of how it's these structures are now big when equipped with isolation. This is a new bridge. Juan Pablo II. By the way, Juan Pablo II, you know, he was the Pope. There are many structures which are isolated that all of them have the Juan Pablo II name in different countries, which is not to be confused. But this is the one in Peru. And this is also quite interesting, also designed by 𝗏𝗏𝗀𝗏, the company I mentioned before from Colombia. Also an interesting application that usually, as a Latin American, when I grew up looking at bridges, I always saw the bridges with the big piers and a lot of concrete. So whenever I see now these structures with these kind of columns and these kind of slender structures, of course, it's not common, but we know for a fact that the isolation is providing these possibilities. And it's interesting because, of course, in many ways creates more sustainable structures. So you have some pictures there. And again, I mean, for me, it's just impressive because this is not common for Latin America to go into that kind of sections. So another one, again, similar. This is a different one from the one I mentioned. That one was red. This is a little bit like orange. This is the 𝗦𝗁𝗃 bridge. And similar way, this was basically launched completely and then put on the elastomeric isolators as well. So they have a very strong understanding of these technologies because, of course, they're also very close to Chile. And Chile has, of course, taken the lead in seismic isolation since many years in Latin America. And Peru has benefited a lot from that, in my opinion. So also congratulations to the Chilean friends, which are really doing a great job. And some other projects in Chile, of course, again, there are plenty, and many of the people here probably work on these projects. Some of the cases that they are doing now in Chile, this is actually with seismic dampers. They have viscous devices there in order to control this bridge. Sorry for the pictures; those are the ones I found. They could have been cleaner, I would assume, but I guess it's not an issue. It doesn't show that it's leaking the damper itself. I think it's something from the top, which again, the expansion joints are not really taken care of properly. So interesting application. You see the devices there, and of course, Puerto Industrial. I think this is also elastomeric isolator. This is a massive project also for seismic isolation in Chile. I'm sure there are plenty of more. Again, because of time, we cannot really show many of them. But again, technically speaking, every single project I'm showing you could take half an hour just presenting the solution and the devices and so on. So whenever you need some information, I'm happy to provide it to you. And of course, you see that the structure is quite interesting. I think I understand, and I don't want to make a mistake, but I think it's the longest in Chile. This bridge. You get a little bit there the full picture of the whole project. And of course, finally, and I don't have that much information. Again, I have just a full presentation of this. I was quite involved in the seismic isolation of this bridge. 𝗪𝗪𝗃 bridge, a 2.7 kilometer suspension bridge crossing from mainland to the island of Chiloé. It's an impressive structure which is now ongoing, and it's really amazing how seismic isolation, energy dissipation, and a lot of devices are involved in this project, because here we have tensions. We have been discussing tensions in some presentations. Here we do have quite important ones. Actually, we had a requirement of testing for uplift forces of up to 3G, which was rough. It was very rough, so we went down to 2G finally. And then I left the company and I don't know what happened, but I will try to find out what happened and let you know. But this is an impressive structure that is happening. You see a little bit where the structure is at the moment, just in some videos. So it's ongoing. It has taken some time because, of course, it's a political project. It happens in this kind of situations, you know, Messina Bridge, similar situation, but this is ongoing, this is happening. It's gonna be isolated with energy dissipation, with holding devices because of the uplift, and it's really an interesting application of technologies. So some other images of how it's looking. Of course, it's a very rough environment, so very interesting project to know more about. And finally, Argentina, which doesn't seem to be the place to be worried about earthquakes, they do have, of course, a border with Chile, where the border is, of course, they get a lot of the activity from that region, and they do have the need sometimes to do isolation or energy dissipation. In this case, this bridge you see there, it's a concrete structure, and it's equipped with viscose dampers, quite specifically. And here I also want to mention the fact that the importance of education. You know, it's we have, again, not only these events, but the fact that in our universities, in our to our students, we teach these technologies. We start to create the spark of why to think about isolation or energy dissipation is fundamental, because that's what really makes the difference. When we got this project, basically they sent us all this. I mean, it was already done, everything. They were so clear about what they wanted. So it's not that you have to do something special. They already have that know-how. And that know-how is what I think has made the difference in Chile, has made the difference in Peru, now in Mexico. So getting prepared and getting ready to understand all these concepts and apply it properly is fundamental for this. Huh? So some pictures of the project. Very interesting one. You see there the dampers are not as big one as the blue ones we saw before, but again, an interesting application. And just to close, finally, I mean, the use of seismic isolation and energy dissipation in Latin America is a reality. It's happening, and it's encouraging, but it's something we have to take very seriously, and we have to be careful about the way we do it. Because of course there are still lack of knowledge that we need to fill in order not to have any situation. Of course, we have now local expertise. We need to strengthen that part. We have a lot of international competition, for sure. A lot of companies now supplying these technologies coming down. But of course, we need to have local production. And we have seen that in countries such as Turkey, where once they have the local production, then the industry, they boost. And I think that's fair, and that's, let's say, the fastest way to have these kind of technologies applied to as many structures as possible. We also have to be very careful about the local regulations. In many of these countries, there are none. In Mexico, we just 2 years ago, we had for the first time regulation for seismic isolation in buildings. We have nothing yet in bridges, and that's a reality in a lot of countries. And as you have seen, I mean, the variations between the codes that you take as a base change a lot. So I think it's important we start to develop those things. Very important, testing capabilities are essential for developing properly and in a safe manner the technologies. Again, I just saw the presentation from Japan. It just strengthened that idea, and especially in our countries. If Japan is having issues, we would need to be even more careful for many other uncertainties we can add into the mixture. So finally, of course, building local capacities and local manufacturing capacity is essential, but with all the highest standards. With seismic isolation, we cannot risk it. We cannot just let them go loose and for manufacture because they want to. We need to be very careful about that. That's where regulation also makes a big difference. And finally, just emphasizing what has been said in the previous presentations, quality control is essential, third-party supervision. I very often find the place where I see the client and I tell them, okay, why did you do that? No, I mean, the supplier told me everything is perfect, and they sign a letter that telling me that everything is fine. And that is risky. You know, it should not be that the manufacturer just telling you that everything is fine. We need to check. So at the end, making sure that this is properly done will give us, of course, a safer society, infrastructure that is resilient, and infrastructure that is sustainable. So that's a little bit the glimpse I wanted to give you about Latin America. Thank you so much for your patience. Wonderful. Thank you very much. Thank you.